I would like to present with you on my topic, biofuel adoption pathway for cargo vessels under carbon tax. So the first question to you is, what is biofuels? And biofuels are actually liquid and gaseous fuels that are produced from biomass. So biomass is renewable organic material that comes from plants and animals. And through thermal, chemical, biochemical conversion processes, biomass can be converted into a variety of different biofuel products. And there are actually 4 major types of biomass. So the first type is the vegetable oils, animal fats, and plants containing sugar and starch. So this type is usually referred as the first generation biomass. The second generation biomass is the woody biomass and inedible oils. The third generation is algae, while the fourth generation is the genetically modified algae. So the purpose of such genetic modification is to enhance the energy conversion efficiency of the algae. So one key advantage of using biofuel is that they are actually considered carbon neutral. And this is because the carbon presented in the biofuels comes from the atmosphere. And even if we consider the life cycle assessed GHG emissions of biofuels, they are actually quite low as well. So also to mention that biofuels can be easily blended with the existing fossil fuels. That means we can use our existing bunkering system as much as possible. And it also means for vessels that are currently running in heavy fuel oil and marine gas oils, so it will be easier for them to implement biofuels as a drop-in fuel as well. So we all understand that in IMO's strategy on reduction of GHG emissions from ships, it aims to peak GHG emissions from international shipping as soon as possible, and to reduce the total annual GHG emissions by at least 50% by 2050. So this is actually compared with the emission level of 2008. However, it is almost not possible to meet IMO's target without any help of alternative energy fuels. So yet, according to the International Energy Agency's latest tracking report on international shipping, almost no low-carbon fuels are used today, with biofuels only accounting for 0.1% of the final energy consumption in shipping. And if the current trend continues, the low and zero carbon fuels could only account for 5% of the total energy consumption by 2050. So actually this value falls severely short of the 83% requirement to meet the emission target. So given the view of the emission reduction target by 2050 and the urgency to implement alternative fuels, so one research question that remains yet to be answered would be which biofuel adoption pathway is more feasible, and at what conditions this pathway is feasible. So in terms of the research methodology, the evaluation of the adoption of biofuel is based on purely, right now, the economic conditions, relative net present value, or NPV in short. So the NPV is actually the result of NPV of a certain ship when adopting a particular type of biofuel, with the subtraction of NPV of the same ship when continue using conventional fuels. So in short, it is the difference of the total annual fuel cost of using biofuels with the annual fuel cost of using conventional fuels, and minus the fixed cost of using biofuel, such as the investment cost and the equipment cost. So actually, our study focused on the first generation biofuels as a start, so namely the biodiesel, which is in the form of palm methyl ester, PME, and the hydrotreated vegetable oil, HVO in short. We have actually designed 3 pathways. The first pathway is the fossil dominance pathway, in which the new built vessels continue using fossil fuels, either low sulfur fuel oil, marine gas oil, or LNG. The second pathway is the biodiesel pathway, or B30 pathway, in which actually 30% of the fuel consumed on board is the biodiesel. The third pathway is the HVO pathway, and actually 100% of the energy used on board is HVO. So also in the table from the third and fourth column, and we have presented the key inputs for the modeling, And the inputs include like cost components, such as capex, fuel costs, and space loss, the fuel components, such as the energy density of the fuel, the mass density of the fuel, the LCA, and the onboard emission factors. Also the ship components, including the vessel specifications, operating profiles, specific fuel oil consumptions of the vessel. So with all these input, we are actually expecting results like the CO2 monetary value to enable the adoption, the fuel requirement, both types and the amounts, and the emission of CO2, both onboard and LCA emission. So here are the results of the pathways. Pathway 1.1 is the fossil low sulfur fuel oil pathway. So actually in this pathway, it involves ships operations without implementing any CO2 monetary value. So you can see a 0 CO2 monetary value there. So the shipping industry will continue using fossil fuels in this pathway, including low sulfur fuel oil, MGO, and LNG. So although there's some adoption of LNG, the majority still use conventional marine fuels due to the economy decision. So if following this pathway, clearly we cannot meet the IMO's target. And the difference in terms of the CO2 emission is very huge. And pathway 1.2 on the right of the table is the LNG pathway. Actually, in this case, we have introduced a 70 USD per ton of CO2 monetary value here to enable the adoption. And as compared with pathway 1.1, we can see an increase in the adoption of fossil LNG here due to the implementation of the CO2 value. However, this scenario cannot meet the IMO target as well, although the difference in CO2 is slightly less. So pathway 2 is the biodiesel B30 pathway. And in this scenario, we have introduced a very high CO2 value, which is 200 USD per ton, to enable the adoption of B30. And this is because of the cost difference between B30 and conventional fuels. And in this case, in addition to B30, the shipping industry will also adopt fossil LNG significantly. And the requirement for B30 will be around 0.9 million tons, and consequently, if we convert B30 to B100, it will be about 0.28 million tons. So as a comparison, the current production of biodiesel worldwide is about 40 million tons per year. So that means we should have enough supply for the whole shipping industry. But however, because we are only using the 30% of blending ratio, that means we cannot meet IMO's target as well. So the last pathway, pathway number 3, is the HVO pathway. So in this case, we introduce an even higher CO2 monetary value of 262 USD per ton, just to enable the adoption of HVO. And in addition to HVO, we also seen the adoption of fossil LNG and bio LNG in this case. So although it is possible to meet IMO's target by simply using HVO, but we have some issues of limited supply of HVO due to the limited feedstock, as well as the potential competition for the usage of HVO, for example, from the aviation industry. So in order to fulfill the pathway, the industry actually requires about 460 million tons of HVO, and that is a very huge number. So usually if without any implementation of fourth generation feedstock, that means the genetically modified algae, it is not possible to achieve this value. So as a summary, we have presented an economic analysis on biofuel adoption pathway on the carbon tax to achieve a net 50% of GHG emission reduction for cargo vessels. We have presented 3 pathways, and the respective CO2 monetary value to enable the adoption is highlighted here. And a key findings here is that a minimum of 262 USD per ton of carbon value should be implemented as soon as possible to achieve the IMO's 50% emission reduction target. And actually, a carbon value lower than that would only promote biofuels that cannot meet the target, or actually would not be enough to encourage the use of biofuels. So because we only focus on the first generation biofuels here, so actually future research could apply the adoption model to other types of alternative fuels, like biomethanol, bioammonia, the renewable ammonia and renewable hydrogen, and even bio-LNG as well. So with that comes to the end of my presentation. Thank you.
Thank you. Question and answer, please. Questions? Anyone? All right. So I'm one of the co-authors. But okay. Anyway, to kickstart, maybe a warm-up question. So in this case, among the different candidates of alternative energy sources, so why particularly biofuel, and how? Because there are so many questions about different alternative fuels. So this is about biofuel. Maybe what is your comment on biofuel versus other types of fuels?
Yes, okay.
This motivates also this particular study.
Okay. Yeah, thank you. Thank you for the question. So actually, why biofuels? As I mentioned, this is just a start of the modeling for the analysis. And we chose biofuels because right now biofuels is treated as a near-term solution for shipping industry. And as I mentioned earlier, there is an urgency to implement alternative fuels here in order to kickstart the decarbonization process. So biofuel is a perfect candidate here to kickstart. And as compared with other alternative fuels, especially like methanol, renewable ammonia, and even hydrogen in future. So we can see that there's still a gap in the technology for these alternative fuels. So that is one of the main reasons why we chose biofuel as a start. And also to know that there are a lot of existing vessels that are using like HVO and MGO. So for these vessels, it will be easier for them to implement biofuels, just to mixing biofuels together with their existing fuels. So without any change of, let's say, the major modification of their engines in order to adopt other alternative fuels. So yeah, that's all.
Thank you. Any question from the floor? Yes?
Good morning. Earlier you proposed a carbon tax of $262 per ton. So I'm just wondering, in comparison to other research for maybe other technologies, how does this compare?
Okay, thank you for your question. Actually, we have checked with other literatures, also the existing studies. Actually, in Europe, they also mentioned similar findings of about above 200 USD per ton in order to actually adopt alternative fuels. So I think our 262 USD is actually reasonable value there. And also if we check, if let's say we check with the current fuel price, like the alternative biofuels, compared with the existing HVO and MGO price, we see it almost doubles the price there. So if, but right now, we know that the price is increasing hugely in recent years, but usually speaking, it's about double. It's about 300 USD difference there. So I think 262 is a pretty reasonable number there.
Thank you.
Thanks. Okay, there is one interesting question. Maybe just a short answer. Is it fine?
Okay.
So one question from Pigeonhole. Sorry. Maybe I'll read out first. The Gen 3 biofuels from algae, what kind of timeline we see to get them a reality, in your view?
Yeah, I think this is a good question. So right now, because it's under development, we are actually, from my perspective, right, if let's say biofuel can be developed smoothly, maybe in 20 years' time, yeah, that means until 2050, we are expecting a new feedstock for biomass. Yeah.
Okay, thanks. Yeah. Okay, so then that's all for this session. Thanks so much.